Hey, what's going on, guys? Let's do these problems right here. The first question is asking block hang from a spring and is set into vertical oscillation with frequency of 1.2 hertz. Calculate the extension of the spring when the block is at the equilibrium position. So first of all, we have to know all the equations related to the frequency. So first of all, we have omega is equal to 2 pi f, and then we have omega square is equal to k over m. So at the equilibrium, we also have mg is equal to kx equilibrium, right? So in this question, they are asking to find the x right here. So we can relate this equation, three equations, and find this answer. So let's rearrange this one. So if I rearrange x equilibrium, that's going to be equal to mg divided by k. So instead of k, what I'm going to do, I'm going to switch this around. Like if I rearrange this one, this is going to be k is going to be equal to omega square times m. Therefore, I can plug this one because we don't have the mass right here, so we can cancel the mass by using this formula. So let's use this. So this is going to be mg divided by omega square times m. Mm cancels, and we are left with g over omega square. But we don't know the omega, but we can apply this equation because we know the frequency. So we can apply this equation in here and find the x equilibrium. So let's apply that. So this we know that acceleration due to gravity 9.80 divided by 2 phi times 1.20 square whole square. And if you calculate this value, this one comes out to be 0.17239 meter. And if you look at this, that's why we got 17 centimeter right here, and that's how we got this answer. And let's do the second problem. Second problem is asking a 2.5 kilogram block is attached to a vertical spring whose spring constant is 110 Newton per meter. It is dropped from the rest with the spring stretched by 12.0 centimeter. Calculate the smallest extension of the spring when the speed of the block is 48.0 centimeter per second. So let's see how we can do this. So in this case, what we can do, we can use the Converse energy equation because we have two different set of energies, right here, beginning and the end. So we can equate that one. So if I do that, we have half, let's say V1 is equal to 1 is the beginning. So V1 square plus mg y1 plus half k x1 square is equal to half mv2 square plus mg y2 plus half k x2 square. So this is the equation we are going to use. First of all, we have to know all the values v1 and like these 1 and 2 values. V1, so this is starting from the rest, so this is going to be 0. Then y1, they are saying is stretched at the beginning, it's in the negative 12 right here because it's already beginning from the 12, so that value is going to be negative. So that is negative 0.120 and x1. So y1 and x1, like whatever the y1 you get, the opposite sign is going to be the x1. So in this case, we got y1 negative 120. That in x1, this is going to be positive 0.120. And now we have all the 1 values. And also they have provided the mass right here, that is 2.5 kilogram. So let's list all the 2 values. So if you look at this, we don't have the 2, y2 and x2, but we know the relationship. Y2 is equal to positive, x2 is going to be negative. That's the relationship we know. And we know the velocity at 2, that is v2 is equal to 48 centimeter per second. If we convert into meter per second, that's going to be 0.480, and that's going to be acting in the opposite direction though, so it's going to be negative 0.480 meter per second. So now we have all the values. We have to simply plug it into this conversion of energy equation, and that's going to give us the x2 value. That's what we are trying to find. So x2 value, let's plug this all. So half m, the first one v1 is equal to 0, so that's going to be 0. Then m we know that already, 2.5 times g is 9.8 times y1, that is negative 0.120, and we have half constant is provided 110 times x1, that is provided, that is 0.120 square. In the other side of the equation we are going to have half times 2.5 times v2 is negative 0.480 square, and we are going to have 2.5, g is 9.80, and y2, instead of y2 I can put negative x2, right? Because we only have to find the x2. We don't want y2. Like if we put y2, we are going to have two unknown variables. That going to make everything complicated. So we can put negative x2 instead of y2. So let's put the negative x2 right here, and then we have half x2 square, kx2 square. So half time k we already know, that is 110. x2 square, we are going to keep it as it is. So now we have this equation. Let's simplify everything. So first one is 0, so we don't have to worry about that. The second one, if you calculate, that's going to be negative 2.94. Then if you multiply this one right here, that gives us 0.792. Then other side of the equation, if you calculate this one comes out to be 0.288 minus this one gives us negative 4.5 x2. Then at last we have 55 x2 square. So we can bring everything to the bring everything to the one side. So we will have a quadratic formula, then we can factor it, right? So let's bring everything to the one side, and if you bring, you will get 55 x2 square minus 24.5 x2 plus 2.436 equal to 0. So now we have ABC values right here. We can plug this into a quadratic formula, that is D is equal, like we are trying to find the x2, so let's put x2 right here. So x2 is equal to minus b. In this case we have negative 24.5 minus c, so minus 24.5, and square root of b square minus plus or minus square root of b square minus 4ac. Instead of b we already know, that's minus 24.5 square b square minus 4ac, so 4 times a is 55 times c is 2.436, 4ac divided by 2a, so 2 times 55. And if you calculate this value, let's use a different color pen right here, let's see. Okay, so if you simplify this one, this is going to be plus 24.5, and in the square root we are going to have 64.33. In the bottom we have 110, and if you square root this one gives us 24.5 plus or minus 8.02060 over 110. And if you calculate this value, I continue this one right here. Okay, so this one gives us 0.14981 or 0.29564. So we have two values right here, but the question is asking calculate the smallest extension of the spring. So in this case we have smallest, this is the smallest right here, Therefore, the right answer is 0.15 meter, but the answers are given in the centimeters. Therefore, this is 15 centimeter, and that's how it's done. I hope you guys liked this video. See you next time.